Okay, welcome to now part 2 of the same lesson for week 4. We'll continue in this part with the types of intermolecular forces. The two major types of intermolecular forces we have to discuss are dipole-dipole interactions and hydrogen bonding. Dipole-dipole interaction, as we earlier discussed, that the type of molecule which is the type of bond which is formed between two atoms with an electronegativity difference is called as polar covalent bond. And in such a bond, the atom which is more electronegative actually applies more force of attraction on the shared pair of electron and pulls it towards itself. As a result, it becomes partial negative. As a result, it becomes partially negative and a pole is generated, whereas the other atom becomes partially positive, and hence in this way two poles are generated. And when this dipole comes in close with another molecule of its same type, then the forces of attraction are established between them, and these forces of attraction are said to be dipole-dipole interaction. Any of the molecule with electronegativity difference establishes such forces of attractions with other molecules, and hence dipole-dipole interactions are found between them. All right, let's see this with the help of this illustration shown in front of you. See, here you can see that we have two HCl molecules. One of the chlorine atom being more electronegative when bonded with an H atom which is electropositive. This chlorine atom pulls a shared pair of electron towards itself and hence becomes partial negative, and whereas H atom becomes partial positive because it is less electronegative as compared to chlorine and more electropositive in nature. Similarly, on the other molecule as well, this is partial negative and hydrogen is partial positive. Now partial negative end of one molecule gets attracted towards partial positive end of another molecule, and the forces of attraction generated between them, they are called as dipole-dipole interactions, because as you people see that two poles have been generated, dipoles have been formed, and the forces of attractions which are holding these two poles of neighboring molecules together, they are said to be dipole-dipole interactions. See the explanation of this illustration as well. The H end of HCl is permanently slightly positive charge. The Cl end of HCl has permanently slightly negative charge. And in this way these poles have been generated, and the forces which are holding these poles together, they are said to be dipole-dipole interactions. All right, now let's come to hydrogen bond. Hydrogen bond is also a type of intermolecular force and is also present in polar covalent molecules, but in this we just limit ourselves to one of the atom is electron deficient hydrogen, and the other atom may be one of the electronegative atoms like nitrogen, oxygen or fluorine. So we have actually limitized ourselves with we have actually bounded ourselves to two types of atoms. One of them is electron deficient hydrogen, that is always electron deficient hydrogen as partial positive, and the electronegative atoms may be any one of them, nitrogen, oxygen or fluorine. So if such a case is there, then the forces of attractions which are operating between the molecules, they are said to be hydrogen bonds. Please do not get confused with the word bond in this type of intermolecular forces. Still they are, this is type of intermolecular forces. Do not get confused the hydrogen bonds with the chemical bonds. Chemical bonds are still much more stronger than hydrogen bonds. Hydrogen bond and chemical bonds belong to intramolecular forces, whereas hydrogen bond belongs to intermolecular forces. The name bond is over here is just referring to the strength, because among the intermolecular forces hydrogen bonds are the strongest ones, but they are still weaker than the chemical bonds. See, the hydrogen has a partial positive charge and the oxygen has partial negative charge, and all of these, nitrogen, oxygen and fluorine, are the most electronegative atoms of the periodic table, and they are electronegative due to the presence of lone pair of electrons on them, which makes them more electronegative. See, the structures, lone pairs are shown over here in front of you. See the lone pair present on nitrogen. Similarly, I am pointing towards the lone pair of oxygen present. 2 lone pairs are present, and on fluorine there are 3 lone pairs are present, which makes it partial negative. Strongly electronegative atoms are involved in it. Let me make it close to you people so you can view it more clearly. All right, so this is all about hydrogen bond, and this is an illustration of hydrogen bond with the help of an example of water. Here you can see the lone pairs on present on oxygen. Due to this, it is partial negative and partial negative terminal. As a result, the hydrogens which are bonded with these are bonded with the electronegative atom, they are partial positive, whereas an association start developing between partial negative oxygen of one molecule of water with the partial positive hydrogen of the other molecule of partial positive hydrogen of the other molecule of water. This is called as hydrogen bonding, and it is strong forces of attractions. Intermolecular forces are present between 2 water molecules, and as a result of the presence of hydrogen bond, water is behaving extraordinary in some characteristics. The extraordinary behavior of water regarding its high heat of high heat capacity and high heat of vaporization is because of and its density. The unusual behavior of water is because of the presence of hydrogen bonds between them. All right, where in everyday hydrogen bonds are applied. Hydrogen bond is occurring in water, and the more unusual behavior of water is due to the presence of hydrogen bonds. And similarly, in human DNA, the structures, various structural structures are made up of they are having hydrogen bonds. For example, in DNA, in proteins, hydrogen bonds are present. Similarly, some compounds like hydrofluoric and formic acids having hydrogen bonds, and this is all about the applications of hydrogen bonds in our daily life. Nowadays, we are also applying the hydrogen bonds applications in epoxy resins or synthetic glues for joining different materials, metals, and different surfaces, and joining different surfaces to provide them chemical resistance and water resistance as well. So nowadays, the hydrogen bonds are also applied in synthetic adhesives as well. We'll talk about that in later slides. Let's move to next. Let's talk about some practical applications of intermolecular forces. Some practical applications of intermolecular forces are in adhesives. Adhesives are some materials or resins which are used to join different surfaces or different metals, different materials. They may be different types of glues you people are using in daily life. Nowadays we have wide variety of glues and adhesives available depending on our uses. Here are some of them are listed for you: German glue, white glue, instant glue. You people are using different types of summat bonds or different adhesives. All of them have the wide variety of applications and purposes involved. The substrates may be some materials like plastic, wood, metal, ceramic, glass, rubber. We have now substrate specific glues available in our daily life. All right, classification of adhesive. We may divide adhesives on the basis of composition, and they may also be grouped together on the basis of their mechanism of adhesion. Generally, we divide adhesives into two main types: natural adhesives and synthetic adhesives. Natural adhesives include starch and glues naturally occurring. They are, of course, cheaply available, but they have then limited uses, whereas synthetic adhesives, they are a little bit costly, but then they offer you a wide variety of applications, like they provide us with chemical resistant applications, then they provide us water resistant, then they provide us strengths, and they are light in weight. They can be used for the surfaces which usually lie underwater, which usually need to be chemically protected. So this is all about the uses of synthetic adhesives. Epoxy resins are being applied nowadays. Nowadays these synthetic adhesives are used for joining different aircraft materials because they do not increase the weight. They provide light. They are light in weight, so they do not add up to the weight of aircraft's parts, making it lighter, and as a result enhancing the applications in our daily life. All right, now let's talk about that bonding actually determines some of the physical properties. Yes, of course, bonding, the physical properties, they change depending on the bonding that is present. For example, if metallic bond is present that exists between metal, the delocalized electrons or the free electrons are involved in this type of bonding. Melting point, it gives a high melting point to the substances having metallic bonding, and the metals are good conductors. They are malleable, ductile and shiny. Whereas if a compound is ionic in nature, then the type of bond is formed between a metal and a non-metal. The electrons are lost or gained in such a case, and the resultant properties are that the presence of an ionic bond gives high melting point, high melting or boiling point to the substance. Then they are good conductors in solution form or in molten form. They are usually solid at room temperature. Similarly, if a compound is covalent in nature, then it means it is involving non-metal and non-metal. The sharing of electrons is involved. Melting and boiling points are low usually. They are non-conductors except for polar covalent compounds, and they mostly are liquid or gas at room temperature. All right, then let's talk about some of the properties. It's merely the same illustration, but the comparison is now between ionic compounds and covalent compounds. The states are different for ionic compounds. Ionic compounds are crystalline solids. Ionic lattices are there. We'll talk about that in a next slide. Covalent compounds are liquid, gases and solids, and they are not in crystalline shapes. Melting point coefficients are high for ionic compounds, low for covalent. Then electrical conductivity, solubility in water, ionic compounds are mostly highly soluble, whereas covalent compounds are less soluble except for polar covalent compounds. Then conduction of electricity, when dissolved in water, yes, ionic compounds are good conductors because they produce ions. Similarly, the covalent compounds, they are conductors only for when it is polar covalent compound is involved. All right, let's talk about the structure of ionic lattice. You may see that there are many ionic compounds. The ions are held together by electrostatic forces of attraction in well-defined crystalline shape. This is the structure of sodium chloride in front of you. You can see the yellow circles are representing chlorine at chloride ions, and then sodium ions are there in red. Both of them are held together by strong electrostatic forces of, and this is the crystalline structure that is formed. Lattice structure is regular grid-like arrangement of atoms in a material. Then ionic lattices, they are hard and the crystals cannot be easily scratched. When dissolved in water, the ions become free, they mobile, and they get mobile, and they are responsible for conducting electricity. And this is an electrolytic cell shown in front of you. We'll talk about in detail the conduction of electricity by ionic compounds in chapter number 7, but still you need to know that when ions are free, when they are dissolved in water, these ions are responsible for conducting electric current, so that makes them good conductor of heat and electricity. Key points. Let's have a quick recap of this whole chapter of chemical bonding. We talked about in this chapter we discussed ionic bonding. Ionic bonding is involving the two types of ions, metal and non-metals are involved, and metals lose electrons to form cations, non-metal lose electrons to form anions, and as a result of ionic bonding they form the compounds formed, they are good conductors of heat and electricity in solutions in molten form, and they form ionic lattices or crystalline structures are there. Similarly, the other type of bonding is covalent bonding. We discussed covalent bonding is between non-metal and non-metal, and this is formed due to sharing of electrons, and as a result the covalent compounds, two types of covalent compounds are formed, polar covalent and non-polar covalent compounds. And polar covalent compounds, we also discussed intermolecular forces that are present, then dipole-dipole interactions and hydrogen bonding. Third type of bonding we discussed is metallic bonding. That is because of sea of electrons, and this sea of electron is responsible for giving characteristic properties to metals like malleability, ductility, high melting boiling points, and conduction of electricity. These are then the properties of compounds we discussed based on their bonding. Ionic bonding, making them high melting point, having high melting point, making them soluble in water, and making them good conductors. Then covalent structures are there, covalent compounds are there which have low melting point, and then they are usually insulators except for the polar covalent compounds. Similarly, we also talked about metallic bonding. Metallic bondings, the solubility in water is low, but melting points are high, and they are good conductors, malleable and ductile they are. Then we also discussed intermolecular forces, two major forces of attractions we discussed, dipole-dipole interactions. They are present in partial charges on two polar molecules, and relative strength is 2 to 10 kilojoules, whereas hydrogen bond is a special case of dipole-dipole force. But in this case we are limited to few of the bonds between like nitrogen hydrogen, oxygen hydrogen, or fluorine hydrogen bonds are involved. So the relative strength is 25 to 50 kilojoules. This indicates that hydrogen bond is the strongest of intermolecular forces present. All right, this was all for now. Now what's next? You should reach to the resource folder to extend your understanding by using online resources provided to you, as well as some written material which is provided to you. Then you should click on the assignment section to find the written tasks which are associated with each learning outcome. Then you should complete your written work and grade it with the key provided later on. So far, that's all. Good luck and thank you all.